It's a huge honor to get this award, and particularly, with Edison as the inspiration and with perspiration as the theme. I'm going to tell you a little bit about 2.5 years ago. I was a magazine editor, and now I run the biggest drone maker in America. We make more drones than all the aerospace companies in America combined. And like, what the heck? I mean, how is that even possible? And the answer has very little to do with me and very little to do with inspiration. A lot to do with the era in which we live in, when suddenly regular people can do extraordinary things. I'm just going to tell you, I'm just going to go very quickly through a slideshow of my story with 3 lessons that I think reflect what's special about this era and what kind of choices we made that ultimately allowed us to be as successful as we are today. And it starts in 2007. This is my daughter, Erin. I have 5 children, and I'm always trying to get them interested in science and technology. And so I started a site called Geek Dad that was all about finding projects that were fun for kids and adults as well. And one weekend at Wired, we got these 2 products in for review. One was the brand new Lego Mindstorms robotics kit. Anybody here familiar with Lego Mindstorms? Yeah, so it just came out. It was pretty cool. And we thought, we'll do that on Saturday. And this other thing was this model airplane. We thought, okay, Saturday we build a robot, Sunday we fly a plane in the park. One of these things will connect. So here's Erin following the instructions with the very first pre-release Lego Mindstorms. And you got to build a tribot. And there's Daniel, her brother. And they spent all morning programming it. And after he did this and he pushed the button, it then did exactly what it's intended to do, which is slowly move to a wall, detect the wall, and back away. And the kids are like, you're got to be kidding, right? We have seen Transformers. Where are the frickin' lasers? And we realized that Hollywood has ruined robotics for kids. You cannot compete with CG. So that didn't go well. Then we decided to take the plane to the field, and we watched YouTubes of acrobatics, and it ended up like that. And that didn't go well. And I had to, the kids were some combination of mortified, and of course it confirmed all their biases about projects with Dad. And ice cream had to be bought. And I thought, and I would get home and I thought, how could that have gone better? We had a robot, we had a plane, and yet it completely didn't work. And I thought, well, what if we'd had a cooler robot and a better flying plane? And I thought, well, what if the robot had flown the plane? That would have been cooler. And I literally Googled flying robot, and the first result was drone. And I'm like, drone. Then I Googled drone, and the first result was autopilot. And then I Googled autopilot, and there was math. And so I stopped Googling, and I got the kids around the dining room table, and I said, let's build a autopilot. And they're like, an auto what? And I said, I think it involves a computer and a sensor and moving surfaces. And so this is literally what the kids and I did. It is the Lego Mindstorms bit. We couldn't actually figure out, so the way airplanes control is they have something called a servo, which moves the control surfaces, but we couldn't figure out how to make the Lego control the servo, so we actually just built this thing so that it just moved the servo back and forth on this little escapement. We put it in a plane, and Daniel's there holding the plane, and we put this picture on the internet in 2007, and it kind of took off. It became sort of a little like Lego UAV, Lego drone thing, and people were like, "That's awesome! You should totally fly that." And so we did, and it did not fly well. And so then we made a better one. And this is that 3rd page of Google results, the one with all the math. We actually went back to that page and actually read some of that. And it apparently had something to do with combining different sensors, accelerometers and gyroscopes and magnetometers, and combining them in some way called a sensor fusion involving something called a common filter. And I didn't really understand, but there was some code I could find on the internet. And so we did it, and we put that one in a better plane, and that one did fly, and that one did work. And that's now actually in the Lego Museum as the world's first Lego UAV. What was interesting is again, this is just me and small children doing this with toy parts. And then as we Googled further, we realized that what we'd made here with an autopilot is essentially controlled as a munition by the US government. It's export controlled. And that when you export autopilot technology, you have to ensure that there is 24-hour closed-circuit television coverage, TV coverage, and that there's a check-in, check-out log, so if any non-US citizens get contact to this. So this, of course, is the Lego autopilot that we just published on the internet. And so what we realized in that moment is that we had, in the eyes of the US government, we had weaponized Lego, which I think is definitely counts as, it was not on my bucket list, but should have been. And I was really kind of looking forward to the moment where, the congressional committee, calls my children up, to testify about how they could have broken national security in this way, because that would have gone viral as well. But sadly, they didn't. Anyway, at that point, the kids lost interest, and I got chills, and I was just sort of saying, how did that happen, right? How did me and my kids end up weaponizing Lego? How did me and my kids end up building a drone out of toy parts? That should not be possible. And there's been 3 times in my life when I really got chills. I was the editor of Wired. I was exposed to a lot of technology, but I only got chills 3 times. One, when I first encountered the internet, or the web rather, in '93. One, when I was with The Economist and I ran the operations in China. And when I first moved to China in '97 and saw what I think is essentially the model of the 21st century, and how everything I'd read was wrong, and this was really, they were gonna pull it off. That gave me chills. And then when I made this robot fly, and using toy parts, that gave me chills. I realized that there was a disturbance in the force. There was a glitch in the matrix. Something in the world had changed, and so I created a website to basically figure out what that was. By the way, 2007 turned out to be the key year. Anybody who was paying attention, who was like measuring the force, if you will, woke up that year. That was the year that the Wii controller came out. The Wii controller had sensors, accelerometers in it, and you could move it. And so the Fitbit guys just bought a Wii controller, and they're like, whoa, this is amazing. I wonder what else you could do with this accelerometer, and they came up with wearables. 3D printing started with MakerBot and RepRap. Arduino, the open source computing platform, started that year. The Maker movement started that year. We had Lego Mindstorms, which also came out that year, and the iPhone was launched that year. And what changed, what actually turned out to be the common factor across all of these was 2 things. One of them was sensors. These little chips inside the Wii controller and the Lego Mindstorms and the phone turned out to have extraordinary applications outside. And the other was the open innovation model of the web. That suddenly, these 20 years of doing things together on the web, we now had the ability to do it in the physical world. And what RepRap and Arduino and all those things were open hardware platforms. They were basically taking open source software models and applying them to communities, and the Maker movement became that. So my community was just about this. And I just created a website, as one does, because I wanted to ask dumb questions. And when you ask dumb questions in public, 2 great things happen. One of them is that people answer your dumb questions, which is good. But the other is that it liberates people to ask their own dumb questions. And in 2007, everybody was dumb about some aspect of this, because it was so multidisciplinary. There was the analog electronics and digital electronics and aerodynamics and power systems and RF and GPS and sensor fusion, and everybody didn't know something in that moment. And it was a beautiful moment where people could be sort of childlike and open about things. Even if they were super experienced engineers in one domain, they had the opportunity to learn about other ones. And these moments when everything's new again, they don't happen very often, where people are kind of willing to come together and be vulnerable and share. That just happened to be 2007. And I think today we're starting to see the payback from that brief moment, the early days of the Maker movement. Unfortunately, we succeeded all too well. This community started creating software and hardware technologies, flying robots of various sorts. And then the next generation comes along, and they say, OK, I'd like to do it. And so this first generation of hackers, which I was one, we think we were done. We documented the entire process. It's like, here is an Eagle file for a PCB design. Just have that fabbed. Then go to DigiKey and order these surface mount parts, and then solder them. And then, of course, build this tool chain, and then compile the code. And they're like, can I just buy one, please? That sounds really hard. Or like, oh, yeah, that'd be a good idea. We need to make a kit. So here's our first production line. We paid the workers with strawberries and juice. Important lesson from this, do not put the 6-year-old on quality control. She doesn't do a good job, and the customers are remarkably unsympathetic. This was the first product. It was a robot blimp. Those are pizza boxes. Blimpduinos, you can say, built on Arduino. The first lesson I learned here, which is not one of our meta lessons, but the first lesson is the very worst thing that can happen to you when this is your production line is that they sell out in 10 minutes, because then you've got to do it again. And I just could not get the kids to do it again. So that was the end of Factory 1.0. But fortunately, I now had built this community on the internet, and there was this one guy who was just the best. He was flying this helicopter with a Wii controller and Arduino, and he was posting code in YouTube videos, and he seemed to be super, super smart. And his name was Jordi Munoz. And I said, Jordi, would you like to build these boards? And he said, sure. And I'd never met him before, but he was open to doing it. And so he sent me a picture, and here's Factory 2.0. And he's soldering the boards, and I'm not, and that worked pretty well. What he did there was he wasn't just soldering board. He told me something important. He said, you should switch to Arduino. There's this thing called Arduino. There's this computing platform, and it's really cool. You should do that. Now, I'd been using other things, Lego Mindstorms, and trying with cell phones and things like that. And what Jordi recognized is that Arduino had an essence that was right, and the essence was not technical. Arduino was based on an 8-bit microprocessor. It was not, it's 16 megahertz. It was not very fast. There were tons of faster technologies out there. But what Jordi recognized is that Arduino was cheap and it was easy. And he recognized that cheap and easy was more powerful than feeds and speeds. And so he steered me towards Arduino. And then what I realized is Arduino was not about the technology, it was about the community. Because it was cheap and easy, it had the biggest community of people. It was a social force, not a technical force. And that meant more people writing code, contributing libraries, willing to use it. And so by using the worst technology with the best community, we ended up coattailing on the Arduino movement, which made it much, much easier to get our things started. We weren't starting from something from scratch. We were adding drone functionality to Arduino, which made it an adjunct to an already hot movement. So that was an insight that he had. I had no idea about this, and he just sensed it with his sort of animal instincts. Then he sent me more pictures. He said, "This is we've got a new space. This is the Factory 3.0, if you will." And I looked at this and I thought, shelves. Oh my God, that is so pro. And then he sent me another picture, and he said, so we bought these pick-and-place machines off eBay, these used ones, and we downloaded the manual from Google, and I would like, you can do that? And yeah, so it turns out that you can. And Jordi, at this point, if the editor of Wired is going to start a 21st century aerospace company, you would not expect he would co-found it with a Tijuana 19-year-old he met on the internet. And yet, that turned out to be exactly the right person to do it with, because what a 19-year-old Tijuana teenager I met on the internet had is, number one, he had, again, these animal instincts about what was hot in technology. He was a child of the internet. Number two, because he was 19, he was completely fearless. He didn't know that you're not supposed to buy pick-and-place machines and reflow ovens and stencil printers and CNC machines on the internet and teach yourself how to use them. And number three, and this is the really key thing, Tijuana teenagers think that building factories is just something you do. It's in the air, in the water, actually quite literally in the air and in the water. But Mark Zuckerberg, when he was 19 at Harvard, was absolutely the right person to start Facebook, but he probably wouldn't have been the right person to start a factory. And yet Jordi Munoz in Tijuana was the right person to start a factory. What do I know about this? And yet it was just the most natural thing for him. So he sends me more pictures. He says, now we've opened our second plant. This is the one in Tijuana. This is the clean room. And, and here I'm thinking, smocks. They've got like uniforms with our logo on it. We're not even a company yet. This is really just working off cash flow, and I sent him $500 advance, just, in case he might need it. And you can't see it in this photo, but I posted this photo on Twitter and at a slightly higher resolution. And the way these factories work is that it's very important to avoid electrostatic discharge, sparking, which will blow the chips. And so what you do is you put a little cable that it's a wristband, and then this little ground cable attaches to the machine. And people saw it and they're like, "You chain your workers to the machines?" Like, oh. Technically, yes. And so then he sends, then there's this picture, and at this point it's like, okay, time to quit my job. So this is just all built organically with teenagers. Now they're not teenagers anymore, but in their early 20s. At this point, I'm like, this is real. So we made a real company. I took over as CEO. That's 2.5 years ago, this is just one of our 5 factories right now. This is the Tijuana factory. And so what we learned there was everything we learned about manufacturing and about the products, et cetera, we learned by actually doing it. Today, we run big factories in China. It's all contract manufacturers outsourced. But the fact that, that we actually did it from the ground up, from the garage, those early boards I soldered myself and loaded the code, and my 6-year-old did QA. I have a really kind of intuitive sense about what this means now. And when you look at all the really interesting hardware companies right now, they all started like Edison did, actually doing it themselves. Square started with Jack Dorsey and Jim, last name, thank you. Building that first Square reader in Tech Shop. There's this beautiful essence of having to actually create something from scratch and improve it and learn the lesson, learn the mistakes and get feedback, the kind of the Kickstarter experience that leads to stronger, more robust, more scalable companies down the line. The only question is whether today you have time. Back then, in 2007, we had years to get this right, and we failed and failed and failed again because the marketplace was sympathetic. Today, those time cycles are shrinking. You've got, once your Kickstarter gets out, it has to be polished, it has to perform, et cetera. And so, the good news is that the tools out there to get to these products are better. But the bad news is that the standard required for hardware is now rising to such a point that you may not be able to put your 6-year-old on QA anymore. So today, this is a little bit what we look like. One of our facilities in San Diego, one in Austin, one in our headquarters in Berkeley. Again, we have factories in Shenzhen as well. And this is the kind of stuff we make. We make the most complex consumer device ever sold outside of a car, I think, with one of the most complex companies in one of the most complex industries ever, competing with one of the most impressive Chinese companies in the world, a company called DJI, which is like, up there with Xiaomi. Just 21st century, do everything right Chinese company. And we think that this is going to be a battle between the open innovation model that came out of the web, that comes out of Silicon Valley, that came out of the maker movement, versus the Chinese monolithic manufacturing model. And it'll be really interesting to see how this plays out. I think that open innovation platforms are going to win, but ultimately, it boils down to hardware. Can we make fantastic hardware that just works better than they can? Does open innovation, does the Android approach beat the iOS approach down the line? So, the reason this is all possible is, again, smartphones. These are all industries that are adjacent to the smartphone industry. The reason we're able to do this, the reason I'm able to go from magazine editor to drone maker is because Apple and Google and Samsung and LG are doing all the work. This is what we call the peace dividend of the smartphone wars, is that all those components, the GPS and the cameras and the ARM processors and the sensors, et cetera, are being made with incredible economies of scale for smartphones. And now they have the ability to transform industries around the smartphone, like wearables and the Internet of Things and smart homes and smart cars and robotics, et cetera. And so you're going to see this explosion of innovation and entrepreneurship and accelerating development all around hardware because we're using smartphone guts, because we're coattailing on this extraordinary revolution happening in our pockets. And we're just lucky to be alive today. And the reason I can be here in front of you is that, in a sense, we just recognized that something special was happening in the mobile space on the hardware side, and then that Moore's Law acceleration, which it's faster than anything we've seen in history, that Moore's Law acceleration was going to change everything around it. And we just picked one of those things. Drones is ours. So that really is follow the money. When I say follow the money, I mean, where is the investment going? Who is spending the most on technology? And whatever they're doing, use that. So we, for example, have Qualcomm as one of our investors. We're using Snapdragon chips in our drones because that's where the money is. And and what we're doing here is really almost looking at social trends. We're looking at monetary trends, and we're just sort of saying, where's the world going? Let's just design our products so they go there too. And so this is the progress that we've made. It's gone from the flying robot to the flying robot with a phone to the flying robot connected to the phone and the cloud, et cetera. And now we just look like the Internet of Things. The more we use smartphone guts, the more we look like a smartphone. So we have, SDKs and APIs and all this sort of stuff. We joined up with the Linux Foundation to make it open. And in a sense, this is why it's happening, that we're seeing this convergence of all these industries, the smartphone industry, drones, Linux, things like the robot operating system, which are really big in academia. As we all converge on smartphone technologies, all these adjacent communities become one. And we can suddenly use the work they've done, and we can suddenly coattail and build on their work. And I just wanted to end with this one slide, which is my favorite book from high school. This is Flannery O'Connor's book, Everything That Rises Must Converge. It's a book of short stories, but it's really my motto. And that's all I've done here is just look at the rising columns around me. Jordy tipped me off to Arduino, which was rising. The community tipped me off to smartphone technology was rising. Linux was rising. That all I do is look at sort of saying, what are people using? What's getting more popular? Where is energy and innovation and talent going? And let's just see where those lines intersect. And I think that this is the reason we're so excited about hardware today, the reason we're so excited about extending the internet to the physical world, the reason that these devices in our homes and our pockets and our wrists are so powerful today is that somebody out there was looking at these converging trends and sort of saying, we don't have to do it all ourselves. We are part of a bigger movement here, this revolution in mobile technology. And by seeing the convergence and getting ahead of it, we can do things in a few years that would have taken decades before, that we can compete with the biggest companies in the world by just being smarter about the trends around us. Thank you very much.